Hello, today we're going to be working on assignment 3.1, which is the one-way ANOVAs. The first thing that we're going to look at, we're looking at means for region 1, region 2, and region 5. So we want to select only that data to work with. So we'll go to select cases, use our if statements where we have region 1, region 2, and region 5, and then hit continue and OK, and it should filter our data to regions 1, 2, and 5. Once we've filtered to the data that we want to start checking our assumptions. The first assumptions we're going to check are our n's, so how many are in each, our descriptive statistics, and the Shapiro-Wilks test for normality. So to do that, we're going to go to descriptive stats, explore. We'll put enroll in as our dependent variable and regions as our independent variable. We're going to check histogram and then normality plots with test, and this will give us our Shapiro-Wilks and also give us our descriptive stats, and hit OK. The first thing we're going to check is our sample sizes. We can see that for regions 1 and 2, we have samples that are large enough to meet over the 30 threshold. But for region 5, we are under the 30 threshold, which means we have violated that assumption. We have a lot of other descriptive stats here, but we're going to scroll down to test of normality. This is going to be our Shapiro-Wilk test. Here we're going to look at each region, region 1, 2, and 5. Our p-value for region 1 is less than 0.001, meaning it is statistically significant, and that group does not have normality. Region 2 is the same at less than 0.001, meaning we do not have normality for that group either. Group 5 has a significant p-value of 0.088, which is above 0.05, which means we do have some normality in that group. Because we don't have normality in every group, we're still going to say we've violated the assumption of normality there. At this point, you would probably want to start looking at a non-parametric test like the Kruskal-Wallis test instead of a one-way ANOVA. Because we're working on one-way ANOVAs for this assignment, we're going to go ahead and continue with that and also take a look at our Levine's test. In order to do that, we're going to go to compare means and proportions and go to our one-way ANOVA. We again have enrollment as our dependent value and region as our independent value. We're going to go to our options and ask for homogeneity of variance test. That's going to be our Levine's test, and we'll throw in some descriptive stats as well. We're also going to estimate the effect size for our overall test so that we have that in the case that we do reject the null hypothesis. All right, we can see, just double checking, our sizes here for our regions are still the same. And then we're going to move to that homogeneity of variances test. This is our Levine test statistic. We're going to use this first row based on means where we see that we have a p-value of less than 0.001, meaning we have failed that assumption as well. Failing all three assumptions really indicates we should move to a non-parametric test. However, we're going to continue to look at our ANOVA results here. So our F value is our test statistic at 2.957. But our significance, our p-value is 0.055. Because this is larger than 0.050, we would actually, in this case, fail to reject our null hypothesis, which is that all the means are equal, and say that there is not a statistically significant difference between these means. In that case, we would not need to look at effect size because if there isn't a difference, we wouldn't need an effect size. However, just for the purposes of this assignment, I'm going to go ahead and read our eta squared, which looks at the effect size for an ANOVA. In this case, our value here is 0.036. That's our points estimate for eta squared. And this indicates that we have between a small and a medium effect size, with our scale being 0.01 for small, 0.06 for medium, and 0.14 for large. And this will conclude our 3.1 assignment.